This tutorial will demonstrate how easy it is to build and configure integrated solutions including CODESYS control in Warp. The project is built in a graphical environment featuring drag and drop. It's intuitive and no programming is needed. Let's take an actual hands-on example and see how easy you can build and integrate CODESYS-based control solution. We start by duplicating the existing I/O node by clicking on the copy-paste buttons in the ribbon menu. The I/O node is renamed to I/O node 2. By navigating in the product catalog, we find the frequency inverter that should be included in our control solution. Select the product and drag and drop it to the workspace. The frequency inverter will be equipped with an EtherCAT expansion card. Therefore, we select EtherCAT 2 port module. Now it's time to configure the EtherCAT network. The X2 control panel, I/O and frequency inverter are therefore connected to each other. In the finalized application, the CODESYS control code will be executed in the X2 control panel. This project will include one more control solution. We will therefore add a HMI, programmable I/O and frequency inverter to the workspace. We type X2 base 7, select it and drag and drop it to the workspace. A programmable I/O is also selected and added to the workspace. We replace the auto-generated text with pump station instead. The programmable I/O is assigned a new IP address. The new IP address is set to 192.168.1.2. We will now add a couple of I/O modules to the programmable I/O. First, an analog input module, then an analog output module. In this case, Warp suggests that the power module should be added to give extra stability to the inputs and outputs. We therefore select the suggested module and drag and drop it to the node. The module needs to be placed between the input and output module. Select a module and move it to the second slot instead. The warning will now disappear. The existing frequency inverter is copied by clicking on the copy-paste buttons in the ribbon menu. The name is changed to BFI2 and the expansion module is changed to Modbus TCP2 port module. The frequency inverter is assigned a new IP address so that it belongs to the same subnet as the operator panel. The new IP address is set to 192.168.1.3. Finally, the operator panel, programmable I/O and frequency inverter are connected to each other in a Modbus TCP network. In the finalized application, the CODESYS control code will be executed in the programmable I/O. Warp includes smart objects that can be added to your applications. The smart objects contains embedded functionality such as PLC code and HMI screens that speeds up your development. The PID control smart object is selected and added to both the X2 control panel and the programmable I/O. The CODESYS code will be injected to the X2 control panel and programmable I/O. The IX code will be injected to the X2 control panel as well as the X2 base panel. Finally, we select the X2 control panel, X2 base panel, and programmable I/O and click on the Generate button. The IX and CODESYS applications are now generated. This part of the video has been edited and runs quicker than normal. At this point, the CODESYS and IX applications have been generated. When clicking on Browse to Project folder, we see all the applications generated by Warp. When navigating in CODESYS project, we notice that structures for the I/Os have been injected to CODESYS. The application is also prepared with variable lists, symbol configuration, task, and I/Os. The I/O modules have been connected to variables automatically and are ready to be used in the control application. The frequency inverter are also prepared and connected to variables. Finally, we notice that a program has been injected. This contains the logic for the PID controller that has been added in Warp. This program is written in function block diagram, but CODESYS supports all editors stated in IEC 61131-3. The PID function block is open when double-clicking on it. This code is written in structured text since it allows better flexibility and overview. When navigating in the IX application, we see that tags have been generated and inserted into the application. A faceplate screen has been injected to the application and is prepared with objects that already are connected to tags. The objects allows you to easily adjust and monitor the PID controller. The applications are now configured and ready to be downloaded to the hardware. To sum up, this software will change the way you create integrated CODESYS control applications forever. We call it Fast Forward Engineering. Download Warp from our Smart Store and start to work smarter.